solve radical equations. Okay, so these are going to be equations that have the radical symbol in them. Okay, good news is they're all going to be square roots. Okay, so if you think about what we've been doing on the previous equations from the first lesson, if the power was like to the 1/3, we raised it to the third power to cancel it out. Well, this time, all we're doing now is we're just trying to get rid of this radical sign. And if this is a square root, how do you get rid of a square root? We just talked about that yesterday. How do you get rid of roots? Raise them to the power. Okay, now, when you are solving an equation that has a radical in it, you have to isolate the radical. So we need to get, so look up here, we need to get that completely by itself before I think about squaring it. Okay, so how would I, like what number would I move? I'm going to go ahead and move that 5 over, and since it was a -5, we're going to go ahead and add 5. Okay, so then, has that radical disappeared yet? No. So go ahead and bring the square root of x plus 3 down. Bring that down, equals, and then 0 plus 5 is 5. Okay, now to get rid of that square root, because right now I can't subtract 3 until that 3 is out of the radical. And so to cancel out the square root, we do what? We raise that side to the second power, and if we raise the left side to the second power, we're raising the right side to the second power. So we are squaring the square root, so that way that symbol's gone. So if you guys look up here, this squared cancels out the root, so this x plus 3 stays x plus 3. There's just no symbol anymore. And then you just have to do 5 squared, which is 25. Okay, so up here at the top where these steps were, isolate, which we did, we have now squared both sides, and now we're solving for the variable. Okay, so what's my only step that's left? Subtract 3. And we get x equals 22. Okay, now it does say check for extraneous solutions. Okay, so watch. When you guys check for extraneous solutions, this was a question on your last test. In order to check them, we have to plug in our answer to the original equation. So my original equation was this. Here was my original. I need to plug the number 22 in where the x is, so watch. Square root of 22 plus 3 minus 5 equals 0. We need to see if that's a true statement. If it is, then the answer of 22 is correct. If it's not true, it's extraneous. Okay, so what is 22 plus 3? 25. And then what is the square root of 25? And what is 5 minus 5? Okay, so look. When I simplified this left side, does it match the right side? Yes. So since when we plugged it in, we got the same answer, it is true, which means our answer was correct. So this is like the check step. And a lot of times you guys don't have to show that, but it is going to be extremely important on these problems that once you get your answer, you need to plug it back in and make sure it is a correct answer, because they won't always be. All right, you good with that one? They don't get much easier than that. Okay, so turn it over. We have three different, there are, three different types of problems on this page that we're going to discuss. I try to a lot of times go in the same order that your practice page would be in so that you can kind of see how to do these. Okay, so we're going to go ahead and do this one next. And then I'm probably going to do number 5, and then I'll finish with these two. Okay, so if you guys take a look at number 2, this radical is not isolated. What number do I have to move? The 1. Now the 1 has been added. Now look up here, please. There is a difference between how this is written and let's just say it had looked like that. See how that 3 is attached to the radical? We would actually start with dividing by 3 first. Okay, this one actually does have a plus sign in there, so since that 1 has been added, we do need to subtract it first. Okay, the radical's still there. So now that the radical's isolated, what do? So we square both sides. And like I mentioned before, squaring a square root only cancels out the symbol. The 2x plus 3 stays exactly the same. And then what is 5 squared? 25. Okay, so now that's a 2-step equation. So how do I solve that? Subtract 3. We get 2x equals 22. And then divide by 2. So x equals 11. Okay, now let's let's do the check. If I take my original equation, it was 1 plus, then under the radical it'd be 2 times 11 plus 3. And supposedly we're supposed to get an answer of 6 if we've done this problem right. Okay. What is 2 times 11? 22. And 22 plus 3 is 25. What is the square root of 25? 5. And what is 1 plus 5? Okay, so look, I only simplify one side. Like I usually just simplify the left side, and then I just look to see, okay, did it match the original answer? Yes. So since that matches, that is a true statement, therefore x does equal 11. All right, let's do this problem next, number 5, because this one's really simple. If you guys look at number 5, you see how there's a radical on both sides? There's one radical here and one radical here, but aren't both of them isolated already? So if they're already isolated, don't we just get to square both sides right from the beginning? Okay, so we're just going to go ahead and square both sides. And when we square both sides, the symbols just disappear, right? So you have 9 minus 1n equals 16 minus 2n. Bless you. Okay, so then how do I go about solving that equation where there's variables on both sides? What do we do? Okay, so I like to move my n to the left. So I started by adding 2n. So the 9 would come down, and then negative 1 plus 2 is a 1n. Bring the equal sign down and bring the 16 down. And then there's only one step left to go. Subtract the 9. So I have n equals 7. And then we need to check to see if this is correct. Okay, so when I go to do my check, the original said this: square root of 9 minus n, which I'm going to plug in a 7 there, is going to equal the square root of 16 minus 2 times 7. So this one I will have to simplify both sides. What's 9 minus 7? 2. Okay, so the left side right now says square root of 2. And on the right side, what is 2 times 7? 2 times 7? 14. And what's 16 minus 14? 2. So do the two sides match? Yeah. So n does equal 7. Okay, go back to the third one. Number 3 and number 4, they both require quite a bit of work. Okay, so if you take a look at number 3, notice how on the right side there's a radical. It is isolated. If the radical is isolated, you immediately start with squaring both sides. So look, the right side is not the issue. Squaring a square root is just going to get rid of the symbol. I'm not worried about that side. What I'm concerned with is the left side. Because if I need to square this whole thing, I would have to put parentheses around x plus 4 and raise it to the second power. Well, what does it mean to square an expression? Don't we have to multiply it by itself? Like, isn't x plus 4 squared the same as... if I were to write it out, isn't that what it would look like? And isn't that a box problem? Because that's a 2 by 2. So this side of our equation is going to be a box. So you're going to have to do some extra work over here to figure out what goes on the left side of our equation. So we have x plus 4 times another x plus 4. What is x times x? X squared. X times 4. And then 4 times x, and 4 times 4. 16. Okay, so it looks like the left side is x squared. Then we've got 8x in the middle, and then we've got a 16 at the end. So this is the left side of the equation. Okay, it's only the left side. The right side is still this x plus 10. So when I look at this, don't you guys see a quadratic? And when I see a quadratic, it has to be set equal to 0 in order for it to be solved. You guys have done a ton of these. In order to solve a quadratic, we just need to move the x and the 10 to the left side. So we're going to subtract an x, and we're going to subtract the 10. Make sure you pair them up with the right thing, the right term. So x squared would drop straight down. 8x minus 1x is 7x in the middle, and then you've got 16 minus 10, which is 6. Okay? Now, to solve this, that's an asterisk problem, right? Sure is. So here we go with some extra little side work down here. We've got a 6 and a 7. What two numbers multiply to give you 6 that add to give you 7? 1 and 6. So there are our two sets of parentheses. We've got x plus 1 and x plus 6 equals 0. Now we should be able to go to our two answers. Yep, -1 and -6. Now there is a really good chance that since we just got two answers, there's a good chance that one of them is false. Okay, when you get one answer, most of the time your one answer is going to be fine unless you messed up somewhere. Okay, when you get two answers, it is pretty common for you to get one true, one false. Okay, so I definitely have to plug these in. So I'm going to start with the -1. So I'm going to go back to my original, and I would write -1 plus 4 equals, and then under the radical, -1 plus 10. I just plugged in a -1 wherever I saw the letter x. What's -1 plus 4? Okay. Now on this side, what's -1 plus 10? And what's the square root of 9? Okay, so is that one true? Yep, that one is true. So the answer of -1, that's a good one. So now there's a chance that, hey, that -6 might not be true. Let's see if it is or not. If I check the -6, I would have -6 plus 4 equals, and then under the radical, -6 plus 10. What's -6 plus 4? -2. What's -6 plus 10? 4. And what's the square root of 4? 2. Okay, look at what mine says. Mine says -2 equals 2. Is that true or false? That is false. And since that is a false statement, that means that the answer of -6 was extraneous. So you want to go up there and you want to just cross out that -6. Now, I don't know if you guys were thinking this or not, but the other day, remember when we did square roots, I said they could be positives or negatives? Looking at this, I mean, technically, couldn't a square root of 4 be -2? It could. The reason they end up saying this one's false is because when we typically want you guys to choose the negative square root, they will usually put a negative sign in front of it. Like, remember how we have the plus, minus in the quadratic formula? That's when you would typically use the negative square root. If there's no symbol here, they want you to say it's the positive, and since it was set equal to the negative, that's what made it false. Okay. All right, and number 4 is pretty much just like number 3, except look up. This radical is not by itself, so don't I have to move the 4 over? And I'm going to subtract 4. Well, isn't that going to give me an expression on the right? It's going to actually say x minus 4 on the right side. Now it looks very similar to how number 3 started. Since the radical is by itself, what do? Well, no, square it. Square that and square this. So this time, squaring the left side is the easy side, because squaring a square root just is x plus 2. The right side is what kind of problem? That's a box right there. We're going to have an x minus 4 times another x minus 4. So x times x, it's x squared. And then x times -4, -4x. And then negative 4 times x is negative 4x. Negative 4 times negative 4. Positive 16. So it looks like this time we end up with x squared minus 8x plus 16. So this was the right side of the equation. But don't we have a quadratic again? And when we have a quadratic, these two terms, the x plus 2, those are going to have to come over here and pair up. So I'm going to get rid of an x and I'm going to get rid of the 2. X squared comes down. And then negative 8x minus 1x is what? Yep. And then 16 minus 2 is a positive 14. All right, you have the quadratic that you need to go ahead and do the asterisk. Let's get that thing factored. What two numbers give you a 14 and a negative 9? What kind?
7 minus 4 and negative 2. Yeah, because the bottom is negative.
So they're both negative?
Yes, negative 1.
They're both negative. Both negatives. They're either both negative or both positive when the top number is positive. So we've got x minus 7 and x minus 2. Which means our two answers are not going to be negatives. They're going to be the positives, right? We get positive 7 and positive 2. And again, since there are two answers, there's a good chance that one of them is extraneous, so we have to do the check. I'm going to start with the 7. When I plug in the 7 up here, this would say 4 plus the square root of 7 plus 2 equals 7. So we need to see if that's true or not. What is 7 plus 2? 9. And what's the square root of 9? 3. Is 4 plus 3 7? Okay, so the answer of 7 is correct. I'm going to do my other check over here just for space purposes. I'm going to take this 2 and I'm going to plug it in. Okay, so let's look at this. What is 2 plus 2? And what's the square root of 4? Okay, so now look at what it says. It says that 4 plus 2 equals 2. Is that true? 4 plus 2 is 2?
Oh, no.
4 plus 2 is 6. So those are not equal, which means the 2 is extraneous. So you're going to cross out that 2, and the only correct answer is the 7. Now listen, if you get two answers, they both may be true. You may plug them in and get two trues. Or you're going to get one true and one false. You should never get two false. Okay, now the ones on the notes, it just so happened that in each of the examples, when we got two answers, one was true and one was false. But don't expect that to happen every time. There are times when both answers are true.